Welcome to my channel guys, this is Pranshi Verma. Guys, in this video we will learn Data Science Interview Questions with answers. Guys, this video is very helpful to all of you if you learn Data Science as a subject as the interview purposes also. So let's get started today's video. In Data Science Interview Question series, your first question is Question 1. What is a recommender system? Answer of this question is a recommender system is today widely deployed in multiple fields like movie recommendations, music preferences, social tags, research articles, search queries, and so on. The recommender systems work as per collaborative and content-based filtering or by deploying a personality-based approach. This type of system works based on a person's past behavior in order to build a model for the future. This will predict the future project buying, movie viewing, or book reading by people. It also creates a filtering approach using the discrete characteristics of items while recommending additional items. Okay, so this is the answer about a recommended system. Okay, next question number 2. Question number 2 is compare SAS, R and Python programming. So guys, answer is हम लोग क्या करेंगे यहाँ पे one by one कंपेयर करेंगे तीनों का. So but firstly we will talk about SAS. It is one of the most widely used analytics tools used by some of the biggest companies on earth. It is some of the best statistical functions, graphical user interface, but can come with a price tag and hence it cannot be readily adopted by smaller enterprises. Okay. Next, R. The best part about R is that it is an open source tool and hence used generously by academia and the research community. It is a robust tool for statistical, computational, graphical representation and reporting. Due to its open source nature, it is always being updated with the latest features and then readily available to everybody. Okay, next, Python. Python is a very powerful open source programming language that is easy to learn, works well with most other tools and technologies. The best part about Python is that it makes innumerable libraries and community created modules, making it very robust. It has functions for statistical operations, model buildings and many more. Okay, next question is question number 3. Explain the various benefits of R language. Answer is the R programming language includes a set of software suite that is used for graphical representation, statistical computing, data manipulation, and calculation. Here, some of the highlights of R programming environment include the following. R is an extensive collection of tools for data analysis. Next one, R operators for performing calculation on matrix and array. Next one, R data analysis techniques for graphical representation. Okay. Next, a highly developed yet simple and effective programming language. R extensively supports machine learning applications. R acts as a connecting link between various software, tools, and data sets. R creates high quality reproducible analysis that is flexible and powerful. R provides a robust package ecosystem for diverse needs. And R is useful when you have to solve a data-oriented problem. Okay. Next question is, how do data scientists use statistics? Answer is, statistics helps data scientists to look into the data for patterns, hidden insights, and convert big data into big insights. It helps to get a better idea of what the customers are expecting. Data scientists can learn about the consumer behavior, interest, engagement, retention, and finally conversion, all through the power of insightful statistics. It helps them to build powerful data models in order to validate certain inferences and predictions. All this can be converted into a powerful business proposition by giving users what they want to at precisely when they want it. Okay, next question number 5. What is logistic regression? Answer is, it is a statistical technique or a model in order to analyze a dataset and predict the binary outcome. The outcome has a binary outcome, that is either 0 or 1 or a yes or no. Okay, next question, that is question number 6. Why data cleaning is important in data analysis? Answer is, with data coming in from multiple sources, it is important to ensure that data is good enough for analysis. This is where data cleansing becomes extremely vital. Data cleansing extensively deals with the process of detecting and correcting of data records, ensuring that data is complete and accurate, and the components of the data that are irrelevant and are deleted or modified as per the need. This process can be deployed in concurrence with data wrangling or batch processing. Once the data is cleaned, it conforms with the rules of the data sets in the system. Data cleansing is an essential part of the data science because the data can be prone to error due to human negligence, corruption during transmission, or storage, among other things. Data cleansing takes a huge chunk of time and effort of a data scientist because of the multiple sources from which data emanates and the speed at which it comes. Okay, so data cleansing is very important in data analysis. Next question is question number 7. Describe unvariate, bivariate, and multivariate analysis. Answer of this question is, as the name suggests, these are analysis methodologies having a single, double, or multiple variables. So, a univariate analysis will have one variable, and due to this, there are no relationship causes. The major aspects of the univariate analysis is to summarize the data and find the patterns within it to make actionable decisions. Next, a bivariate analysis deals with the relationship between two sets of data. These sets of paired data come from related sources or samples. There are various tools to analyze, such as data including the chi-square test and t-test, when the data are having a correlation. If the data can be quantified, then it can analyze using a graph plot or a scatter plot. This the strength of the correlation between the two data sets will be tested in a bivariate analysis. Okay. Next question is, how machine learning is deployed in real-world scenarios? Your answer is, here are the sum of scenarios in which machine learning finds application in real world. One is e-commerce. In this, understanding the customer churn, deploying targeted advertising, remarketing. Okay. Next one, search engine. Ranking pages depending on the personal preferences of the searcher. Next one, finance. Evaluating investment opportunities and risk, detecting fraudulent transactions. Next one, Medicare. Designing drugs depending on the patient's history and needs. Next one, robotics. Machine learning for handling situations that are out of the ordinary. Next one, social media. Understanding relationship and recommending connections. Next one, extraction of information. In this, framing questions for getting answers from databases over the web. Okay, so these are the real world applications of machine learning. Next question, question number 9. What are the various aspects of a machine learning process? Answer is, in this particular post, I will discuss the component involved in solving a problem using machine learning. First one is domain knowledge. This is the first step wherein we need to understand how to extract the various features from the data and learn more about the data that we are dealing with. It has got more to do with the type of domain that we are dealing with and familiarizing the system to learn more about it. Next one, features selection. In this step has got more to do with the features that we are selecting from the set of features that we have. Sometimes it happens that there are a lot of features and we have to make an intelligent decision regarding the type of features that we want to select to go ahead with our machine learning endeavor. Okay, next one, algorithm. This is a vital step since the algorithm that we choose will have a very major impact on the entire process of machine learning. You can choose between the linear and non-linear algorithms. Some of the algorithms used to support vector machines, decision trees, naive Bayes, k-means clustering, etc. Next one, that is training. This is the most important part of the machine learning technique and this is where it differs from the traditional programming. The training is done based on the data that we have and providing more real-world experience. With each consequent training step, the machine gets better and smarter and able to take improved decisions. Okay, next one is evaluation. In this step, we actually evaluate the decision taken by the machine in order to decide whether it's up to the mark or not. Okay, there are various matrices that are involved in this process and we have to first deploy each of these to decide on the efficacy of the whole machine learning endeavor. Next, optimization. This process involves improving the performance of the machine learning process using various optimization techniques. Optimization of machine learning is one of the most vital components wherein the performance of the algorithm is vastly improved. The best part of optimization techniques is that machine learning is not just a consumer of optimization techniques, but it also provides new idea for optimization too. Next one, that is testing. Here various tests are carried out and some these are unseen set of test cases. The data is partitioned into test and training set. There are various testing techniques like cross-validation in order to deal with multiple situations. Okay, so these are the various aspects of a machine learning process. Okay, I hope guys you understand it. What do you understand by the term normal distribution? Answer is, it is a set of continuous variables spread across a normal curve or in the shape of a bell curve. It can be considered as a continuous probability distribution and is useful in statistics. It is the most common distribution curve and it becomes very useful to analyze the variables and their relationship when we have the normal distribution curve. The normal distribution curve is symmetrical, the normal is symmetrical. And the non-normal distribution approaches the normal distribution as the size of the sample increases. It's also very easy to deploy the central limit theorem. This method helps to make sense to data that is random by creating an order and interpreting the results using a bell-shaped graph. Okay, next question is, what is linear regression? Answer of this question is, it is the most commonly used method for predictive analytics. The linear regression method is used to describe relationship between a dependent variable and one or independent variable. The main task in the linear regression of fitting a single line within a scatter plot. The linear regression consists of the following three methods. First one, determining and analyzing the correlation and direction of the data. Second one, deploying the estimation of the model. Third one, ensuring the usefulness and validity of the model. It's extensively used in scenarios where the cause-effect model comes into play. For example, you want to know the effect of a certain action in order to determine the various outcomes and extend to effect the cause has in determining the final outcome. Okay, so this is all about linear regression. Now let's wind up this lecture. See you in the next lecture.